All right, guys, we discovered some theorems, some ways to prove triangles similar the other day with side, 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 and side angle side, and just wanted to look at a couple quick examples to see how we can put that into practice. So we saw that if we have two triangles here that have all the sides congruent, or similar, that is, so if this is like 2, 3, and 4, and maybe these ones are tripled, so this is 6, 9, and 12. If all the sides are the same ratio, then those are similar. Or if we know that only two of the sides are similar, but we know the angle in between it is congruent, that is enough to say that the triangles are similar. So that is side, 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 and side angle side. So here's our theorem. This is side angle side, similarity. And again, we're saying that we've got these angles congruent, like X and M are marked congruent, and these other sides are proportional. All right, they're in the same ratio. So that is, if this is 4 and this is, well, let's see, this might be 6. How about that? This might be 3 and this would be 4.5. And if you check those ratios out, then 3, well, we could say this, 4 is to 6 as 3 is to 4.5. And if you cross multiply these, you'll see that they're the same thing. They're both 18. Or if we simplify them, if you divide them, you'll get 0.6 repeating on a calculator. If you divide these, you'll get 0.6 repeating. Okay, they're the same ratio. All right? So here's how what we can do with that. All right? If we have some triangles here, actually I think I just skipped one. Let's look at this here. Some of us looked at this in class, but we're looking for congruent angles. We got one there. And then we want to look at the sides to see if they're similar. So we got congruent angles, and we need two sides. Now, the easiest way to probably do this is to look at the two sides of the same triangle. There's two sides, and that's 2 to 3. And I chose to put the smaller one over the big one. It doesn't really matter. Okay? I could have put 3 over 2 there. But then if I compare these two, that's 3 is to 4.5. Okay? The question is that equal? Well, we can find out by dividing it on a calculator. If you divide this out, you'll get 0.6 repeating. If you divide this out, you'll get 0.6 repeating. That means they're the same ratio. You could also cross multiply. 2 times 4.5. Is that equal to 3 times 3? I think it is. They're both 9. Okay? So yes, the sides are proportional. So these are similar by side angle side similarity. And that's how it works. Okay? So we look at these guys here. Do we have a congruent angle? Yep, we do. Angle R is congruent to angle N. Are the sides proportional? Is 24 over 28 equal to 18 over 21? Well, one nice way to do this, you could cross multiply, but we could simplify the fraction. That's probably the easiest way to do it here. I think 4 goes into both here. 4 goes into 24 6 times. 4 goes into 28 7 times. I think 3 goes into both of these. 3 goes into 18 6 times. 3 goes in there 7 times. Yes, 6 sevenths is 6 sevenths. So these are similar by a side angle side similarity. And that's how we prove it. How about this one? Well, we got congruent angles there. We've got angle XZY is congruent to angle XZW. So we got a congruent angle. And let's check the sides. Notice they're connected here. Now the sides we want to compare here is the ones that make the angle. So that's our congruent angle there. We don't care about 15. On the left triangle here, there's our right angle. We don't care about the 20. It's nice that it's there. Now, we could come back and look at side, 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 but if we're doing side angle side, then we've got this ratio. 9 is to 12. And we've got this ratio. 16 is to 12. Oh, wait a minute. Watch out. That's not going to be equal because I put small over large on the left, and I put a large over small here. Well, that comparison's not going to work at all. So let's fix that up. Let's take 12 over 16. So The 9/12 comes from one triangle, and the 12/16 comes from another. Are these the same? Well, simplify it. 3 goes in there 3 times, 3 goes into 12 4 times. 4 goes into 12 3 times, 4 goes into 16 4 times. Yes. So these are similar by side angle side. Okay? Now, we're going to look at our last one here, and that is, what if we don't know any angles and we just have sides? Well, that's good enough. This is side, side, side similarity. If we don't know anything about the angles, like we said at the beginning, but we have sides that are proportional. Maybe this is 4, 6, and 8. Notice I just made them all double. That's good enough. Those triangles would be similar. We don't need to know anything about the angles. So here's a question. Which ones of these are similar to ABC? Are these two triangles similar? Well, if we check their ratios, then we'll be good to go. Let's see. 8 is the smallest. Now, you got to be careful here. Do I match 8 up with 12? No, I don't think so, because 12 is the largest and 8 is the smallest. So I got to find the smallest. When we're matching these up, you've got to match it up to the right one. 8 is the smallest, and so 6 is the smallest. Great. Now look for the largest. 16 is the largest one here. 12 is the largest over here. So let's go 16 over 12. We've got to see if that's equal. We also have to see if this is equal to the medium side and the medium side. Okay? So we got to compare small with small, large with large, medium with medium. Okay? And we're comparing triangle to triangle here. Okay? Well, again, to find out if these really are equal, we could use a calculator. 8 divided by 6 is 1.3. It's going to be like that, okay? Because it's 1 1/3, all right? And if you check all these out on a calculator, it's going to be 1.33. Okay, that's pretty good. Or better yet, if you just simplify the fraction, that's 3/2. 4 goes into both of these. 4 goes in there 3 times. 4 goes in there 2 times. 3 goes into both of these. Oh, wait a minute. Uh-oh, 3 goes into there 4 times. Oh, let me back up. What did I do? Yeah, we got a problem, huh? So, well, maybe we don't. Maybe I do have a problem, but my problem is I don't know how to factor. No. All right, so if we divide these by 2, let's try that again. 4 goes into 8. 2 goes into 8 4 times. 2 goes into 6 3 times. And then 4 goes into both of these. 4 goes into 16 4 times. 4 goes into 12 3 times. Now we're cooking. 3 goes into 12 4 times. 3 goes into 9 3 times. Hey, those are all the same. So yes, we can say that these triangles are similar. Let's make a similarity statement. Similarity statement's going to be like this. Triangle ABC is similar to, now watch out, AB, those my first 2 letters are AB. That's the short side. Okay? A is between the long side and the short side. So which angle over here is between long and short? Well, that's D. D is between long and short. So I got to put D first since A was first. Okay? B is second. B is in between the short side, the shortest side, and the medium side here. So which one's between short and medium? Well, that's going to have to be E. So E is that one there, all right? And last but not least, the only one left here is F. Okay? So they're similar by side, side, side similarity. Okay? That's the key. Now, if we check, are these two similar here? Let's do a quick check. Let's compare the longest side, 16 to 16. Well, that's the same. Compare the smallest sides, 8 to 8. Hey, that's looking good. Compare the medium sides, 12 to 10. Those are definitely not equal. These are equal over here, but these are not similar because they don't have the same ratio. So it doesn't pass the test. So that's the idea. If we have 3 sides similar to 3 sides and the triangles are similar, that's good enough. All right, well, we'll leave it at that. And you should be able to go forward with that and work on finding triangles similar by side angle side or side side side.